In this video, we're going to look at the scale of black holes in the universe. But we're going to do it in a way that's a little unusual to do these things justice. First, we need something big to compare them with. So let's use our solar system. We're going to make a scale model of our solar system, somewhere where we can get a good sense of that scale. Like here in Manhattan, New York, the first thing we need for a scale model is Earth. And we're going to make it the size of a grape. Here, if the Earth is a grape, the Sun is the size of a large elephant. It's pretty huge, but this is a little too close. We need to put it 400 meters or 4 football pitches away. Let's add in the other planets of our solar system here in New York. There's giant Jupiter. It's about the size of a beach ball. The last major planet is Neptune. It's out beyond the Statue of Liberty, 11 kilometers away from the Sun. It's about the size of a melon. You can see why it's difficult to see Neptune. We're on a grape trying to look at a melon in the dark, almost 11 kilometers away. But now that we've got our scale sorted out, how big is the smallest naturally occurring black hole? Compared with the solar system? Well, it would be just this big, smaller than a fine grain of sand. Black holes are tiny. It's obviously much smaller than the Earth. It's about the same size as the asteroid that wiped out the dinosaurs, which is also surprisingly small. Black holes can be smaller than asteroids. Isn't that crazy? Now you might think, well, that's a special, tiny black hole that doesn't have much in it. But it's not. That grain of sand started out as this, an A-type star 10 times wider than the Sun and 35 times the mass the size of a large hot air balloon on our Earth grape scale. When a huge star like this reaches the end of its life, it explodes in a supernova. I've sped it up here a lot. Most of the star bursts outwards, forming a huge cloud of gas and dust thousands of times bigger than our solar system. But it leaves behind a core of iron and nickel a little smaller than our Sun, but with more than 2 times the mass, and the iron and nickel atoms just aren't strong enough to resist the crush of their own gravity. It collapses and atoms are so empty they almost seem to disappear. When they're crushed down to a clump of neutrons called a neutron star. It's so dense, you can see it bend light around it. If it's as heavy as 2.2 suns, or more as it is in this case, even the neutrons aren't strong enough to fight their own gravity. So it collapses one more time to form a black hole. The mass of more than 2 suns is now inside a black sphere just 13 kilometers across. Smaller than a fine grain of sand on this Earth grape scale, but black holes aren't quite what they seem. Now, just to get close up with a black hole for a second, a black hole is 2 things. There is something in the middle called a singularity and a black sphere around it called the event horizon. Let's chop it in half for a moment. Basically, inside the black hole, the singularity is the crushed core of the star. The exact size of the singularity is still a bit of a mystery because it breaks our current theories of the universe. It may have no dimensions, just a dot, or it may just be incredibly small. We can describe the world outside the event horizon very precisely, but for now at least, the singularity requires improvements to our understanding of physics to fully define. It doesn't help that we will never see it. This is because this crushed star has so much mass that it reaches out with its gravity and pulls everything nearby in, including light, creating this black sphere around it. The event horizon, it's a cloak of blackness that we think is probably just empty. It just marks the point of absolutely no return for anything. But you're not simply safe outside it. Gravitational gradient. Small black holes in particular have something called a gravitational gradient. All that means is when you get close, you will inevitably be turned into spaghetti. Seriously, you are pulled much harder at the front of your body than at the back, and it will just stretch you out more and more, the closer you get to it. It's called spaghettification. With really big black holes, that doesn't happen until you're inside the event horizon. But whether it's inside or outside, you can't avoid gravity. When you get close to the singularity, you will inevitably be ripped to shreds very quickly. I often hear people say they'd like to fall into a black hole just to see what's inside, but I wouldn't recommend it. If you're lucky and it's a huge black hole and you can avoid all the other matter falling in with you at incredible speeds, you'd pass the event horizon and you'd likely momentarily see only darkness in the direction of the singularity, not be able to tell anyone about it, and a fraction of a second later you'd be instantly turned into spaghetti. Black hole size. Black hole size. So this is the theoretically smallest black hole we can have, But the smallest we found is a little bigger and likely around 6.3 solar masses in weight. It's the size of a fine grain of sand. If you thought it was hard to find a melon-sized Neptune, imagine trying to see an absolutely black grain of sand in the blackness of space way outside the solar system. We have to look for either its immense gravitational effect on things, its ability to bend light around it, or the incredibly intense light given off when things fall inside them. Black holes and galaxies. So why have I made this huge scale model of the solar system? If black holes are the size of grains of sand, well, it's because black holes don't just like eating spaghetti. They like eating stars too. So to understand the next bit, we need to talk about galaxies briefly. We live in a galaxy, the Milky Way, about here. We're still learning a lot about how galaxies form, but in the early stages there's a lot of matter and young stars in the center of this mass. And that means big stars absorbing each other and becoming black holes. In fact, there's likely to be black holes absorbing other black holes, making these huge black holes growing bigger and bigger, eating more stars and matter and black holes. Eventually, only one wins, and that winner is a supermassive black hole. They're naturally right in the middle of the galaxy. We now believe there's one at the center of almost every galaxy. We have one at the center of ours. We've even taken an image of it. It's called Sagittarius A star, and it is huge. The smallest black hole has a mass of a little over 2 suns, while Sagittarius A star has a mass of 4.3 million suns, which is ridiculous. Now, the reason it has this bright ring around it is because it's currently eating a star. This is the gas of that star being ripped away and accelerated to incredible speeds and temperature before being pulled into the event horizon. It's a flat ring of material, but it looks like it's above and below it too, because the black hole bends the light around it. It's an optical illusion. How big is it? So how big is this thing on my solar system scale? If it's got 4.3 million suns in it? Well, black holes are a bit underwhelming in terms of scale because they crush big things into tiny things. What's impressive, really, is their crushing ability and how much they can fit inside them. So if I just showed you its size, I don't think I'd be doing it justice. So I thought the most interesting way to visualize a 4.3 million solar mass black hole would be to watch one grow by feeding it 4.3 million suns. So here they are. The amphitheater of light. This ridiculous amphitheater of light is what 4.3 million suns look like on this scale. I've had to make this cap of stars 50 kilometers in diameter, just so we can see the individual stars. I've put that grain of sand-sized black hole where my hand is here, close to our own sun. So that will be the first one to be eaten. This is normally how stars are absorbed. They're stripped of their matter, forming this accretion disk. We're going to have to speed this up in this crude simulation. In reality, the process to gain so much mass probably takes hundreds of millions of years. But by actually seeing the equivalent mass that this black hole has eaten, it should hopefully give us a better sense of scale of just how massive Sagittarius A asterisk really is. When I first started this video, I knew the numbers, but I couldn't wait to see this to actually see what 4.3 million really means. You can fit more than 1 million Earths in the sun, and each one of these dots is a sun, in this almost endless sea of light. It should also be noted that the sun is actually an unusually heavy star. It's heavier than 95% of the stars in the universe. So 4.3 million suns of mass is even more incredible. As Sagittarius A asterisk keeps absorbing stars, it will eventually reach 70 meters in diameter on this scale, about 20 times wider than one sun. But containing the mass of all of these, that's actually not very big at all. It's just the size of a big star. It wouldn't reach the planet Mercury. And for instance, it's a lot smaller than the star Betelgeuse in the constellation of Orion. So if you already knew there was a supermassive black hole at the center of our galaxy, you might have envisaged this terrifying, huge object slowly sucking up the galaxy. But it's not. It's this magnificent black star-size object of incredible power. Just don't get too close to it, and you'll be fine. Tom 618. There are even bigger supermassive black holes, too. The largest we found so far is inside a quasar called TON 618. A quasar is an incredibly bright center of a galaxy. It's like a lighthouse. And quasars are the brightest thing in the entire universe. They're powered by an ultramassive black hole, accelerating matter to incredible speeds and temperature, blasting out energy from the black hole's accretion disk, forming two jets of plasma bursting out to the poles of the black hole. The TON 618 black hole is even bigger than 70 meters because it has more solar masses in. So let's feed it those extra suns, and let's have it grow from the Sagittarius, a star-sized black hole to the size of TON 618. So on a scale where the Earth is the size of a grape, the Sun is the size of an elephant, and the smallest black hole is the size of a fine grain of sand. The black hole at TON 618 is about 650 kilometers or 400 miles in diameter. That's 27 times the diameter of the solar system out to Neptune. It has the mass of 41 billion suns. This single black hole has more mass than our entire galaxy, the Milky Way. We think of black holes as star eaters, but really, they're galaxy eaters. Thank you for watching my video on the scale of black holes. I hope you enjoyed it and maybe learned a little about these crazy little star crushers.